Oh, just one thing I wanted to point out. I hope you should be pulling the class code, the code that I commit to. And I think I didn't mention this yesterday, but what I did was I posted what the kind of answer that I was expecting or hoping for, at least one possibility. Again, since everything was an integer, what I wanted to do was just make sure that you were clear on how integers worked and how they weren't automatically converted into doubles except under certain circumstances. So again, just to reiterate, those of you who used floats, please use doubles instead of floats. And the second thing is that it's really important to understand how this integer division works, because it comes up in a number of different contexts. So in this particular one, the way I chose to do it was to have a running sum that was going to be an integer, initialized to 0, and then increment each one, and then make sure you close the scanner. That's something the book is not so great about. Again, for system in, it's not such a big deal. It just in general, it is a good practice when you are utilizing system resources, whether reading from the console, reading a file, reading from the network, to always close those resources when you're finished with them. And then really the point of this was the fact that if you used all integers and you didn't have this cast to a double that turned sum into a double and then divided by the number there, then you would get the wrong answer. So that's just sort of the key to what that was about. Okay, so today we're going to talk about some of the methods that are in this math class. As I mentioned earlier in the course, Java does not have functions, but it has things that kind of act as functions. So the difference you could think of as kind of splitting hairs. They use something called class methods, which are indicated via a static modifier. We've seen that right from the get-go with our main method, public static void main. The static piece there says that rather than an instance method, it is a so-called class method, or you can think of it as a static method. And the math class has a number of these that are just convenient functions, function-like methods that are useful. It also has some useful constants, which again, Java kind of finesses the idea of constants by using these public static final variables. And then we'll talk a little bit about formatting the output. Those of you may have noticed that if we just kind of use print line for a floating point value that has a whole bunch of decimal points, then you see all that stuff. Typically, you don't need to necessarily see all of those. And so formatting the output is, again, we'll cover the basics of that. There's a lot one can talk about with respect to that. There are basically kind of two approaches that Java has. And there's one that I find personally a little bit more convenient. But that's probably because of my background in programming other languages. But you know, that's just me. Okay, so all right, so the math, it's part of the Java Lang package. It was there since version 1 back in the mid-90s. And what it does is it has these static methods that perform a number of mathematical functions, things that you would typically want to do and not be implementing yourself. So things like taking the absolute value, taking the square root of something, taking exponentiation, sort of taking a number and raising it to a power, trigonometric functions. There are others like ceiling and floor, and there are a whole bunch of others like that. So these are, as I said, static methods, sometimes called class methods. I'll use the two interchangeably. And the difference between a static method and an instance method that we've talked about have to do with how they are invoked. An instance method is invoked on an object. A static method is invoked on a class. So in other words, so here's the cosine method from math. And then notice that there's math is the name of the class. This is the name of the class. So it's not an object, it's the class. And here's the square root. Again, for historical purposes, they call it squirt. And we're going to go a little bit further when we get to chapter 7. And the book has this quadratic example again. So the idea is that when we're solving a quadratic function, a quadratic formula, we have the a, b, and c exponent, the exponent of the square, the exponent of the linear term, and then the constant. Then again, notice that they used, even the book starts using doubles here. When we're doing these kinds of computations, you always want to use doubles. So, and that's why I emphasize that just in general, if you're using floating points, use doubles. So here it prompts for integers for the a, b, and c, the different exponents. And then notice this assumption here. It assumes a positive discriminant. So here we're using this is the exponentiation function. So we're using math_pow. In some languages, they have built into the language a double star for exponentiation. And for historical purposes, Java decided to omit that. Was that the best decision? At the time, it seemed to be, because their reasoning was, okay, if I want to take something and square it, I can just multiply the two values together. Or you can use this built-in function of math.pow. And so they wanted to keep the language as small as possible. So they took some things that they felt were optional, and then they just kind of tossed them out. And of course, as I've mentioned before, Java didn't stay small. The language itself stayed very small, but it just, the class libraries just got huge. In fact, for me personally, it's been a bit of a frustrating experience because they've been adding things to Java faster than I can assimilate them. So that's one of the frustrating things for me. In my early languages like Fortran and Pascal, I was able to pretty much touch everything in the language after a certain amount of time. In Java, it's just kind of this moving target. So anyway, but the point is that there's a basic amount of stuff that you can master, and then be able to have a functioning capability in writing programs. Okay, so this is fairly standard stuff. We have the discriminant here. That's the b squared minus 4ac, and then the roots are based upon the square root of that discriminant, minus b over b plus this the whole thing over 2a, and then you print the root. Now, here's where things are kind of a little bit wonky, because if you type in values that'll produce a complex number, or that is a negative discriminant, then you'll just get a runtime error. So this is a fragile type of thing. And just in general, when you're receiving input, whether it's directly from a user like this, or more typically when you're reading in data from a file, or even from the network, you want to, it's the responsibility of the program to make sure that the data is okay. So and the problem is that we haven't covered yet the things that are required to do this. So again, that's kind of what it's going to look like. But what you really should do here is have a test that says, basically, if the discriminant is bigger than or equal to 0, if the discriminant is, let's say, bigger than or equal to 0, then you can do all this, and otherwise say, hey, these are complex numbers. So in that case, what you can do is you can do one of two things. You can say, oh, by the way, you've input bad data, or what would be more user-friendly is you can compute the complex roots, which you can easily do. Okay. So what is that? What is the missing piece here? We haven't talked about the if-else construct yet. However, you are all familiar with it, so hopefully nobody is freaking out by this construct. But that would make this a more robust program, and that's something that we're kind of after. And then, for the example that they have, then notice that we have these roots here, and then since we're just printing it out, you have all this gobbledygook. So that leads naturally into, okay, we want something that's a little, a little bit more, say maybe something like minus 0.6. Let's say we wanted 4 decimal places, it would be 0.6667. So how can we do that? Well, I say presented properly, presented nicely, so presented in a way that the user can really see what's going on. So there are 2 ways of doing this. Okay, and this arose when Java first came out. This was the only way that they had to do it, and they did it in kind of a nice object-oriented way. They have this class called number format, and that allows you to take values, and we can values as currencies or percentages or just various other things. And then a kind of a subclass of that is the decimal format, which I've, before they introduced the printf stuff, which we'll talk about in a little bit, this was the main thing that I used. In other words, with the work that I do, mostly deals with data, numerical data. And so formatting it using the decimal format was something that I used more than other types of things. Okay, so so the number format has some static methods that, again, this is something called a factory approach. You don't have to worry about that term, but again, we've talked about static methods, and what it has a couple of static methods that return a formatter object. So if we're doing currency or percent, and then each of them has a method called format, and that format returns a string with basically with the data and it takes the input as a number and returns a string with the appropriate types of things. So again, their example. Okay, notice that they have a local final variable. Again, normally this would be like a static variable. Again, for this example, it's not such a big deal. But remember, percentages are out of 100. So again, they're reading in some stuff. So we have a currency instance and a percent instance. So they enter the quantity and the unit price. And, so if we want 5 at a unit price of 387, then the subtotal is the quantity times the unit price. Okay, so presumably that's what that would be. And then the tax, see, we take the subtotal, multiply it by the tax rate. And again, this is why you want to you want to use variables like this. So notice that this tax rate is occurring several places throughout that. And that's why you want to define the moral equivalent of a constant variable like this. And notice that it's all uppercase with an underscore, which is kind of an indicator. I mean, it's not a guarantee, but it's an indicator that it's meant to be a constant. So why is that useful? Well, supposing they decide to change the tax rate at some point, and instead of using this variable, you've put this number everywhere in the code. Well, if that number changes, then now you have to go searching through the code for 0.06 and find it everywhere and make sure you change it. And Murphy's Law says you're going to miss at least one. On the other hand, if you've used this variable, this constant variable, which is kind of an oxymoron, then all you need to do is change it in this one place right here, and then it will change everywhere that you've used it. So that's why you want to use something like that. We're going to see an example of that with some mathematical constants that are actually in the math class. Okay. So here's where they're using the format. So this format 1. So you notice that it formats this subtotal, which in general is going to have might have more decimal places. And likewise, it formats the tax as a currency and then formats the tax rate as a percentage. So notice the value of tax rate is, remember, it was 0.06, but because it was formatted as a percentage, they multiplied it by 100 and added the little percent sign here. So that's what that formatting does. And then likewise here, we're formatting it as currency. So that makes sure that when you're formatting it as currency, at least in American currency, then it makes sure that there are only 2 decimal places afterwards for the cents. Because having a fraction of a cent doesn't really make any sense. And when you're doing things like computing taxes, like at a certain percent like this, then you will tip the actual number will come out to be not in whole cents, but in fractions of cents, and it gets rounded. Okay, that was number format. Now decimal format, we can use to format a floating point value that again, either floats if you happen to use them, which you shouldn't, or doubles in all of our cases. So typically what you might want to do is say, I only want to see 3 decimal places here. So what the decimal format class did was it had these patterns And it's a fairly, it can get fairly involved, but the main thing is that they have these hash signs to represent the numbers. So if I want to have 3 decimal places, then the string that I would give it would have 3 hash signs to the right of this is the decimal point right here. Okay, so here's kind of an example here. There is their example. So we're entering the circle radius as an integer. Okay, so here's where a static variable is being used in math, and that's pi, because there's only one value of pi. Now, of course, it is not, how should I say, on the computer, we cannot represent pi exactly. In fact, nobody can represent pi exactly. We can represent pi approximately, and it represents pi to a bunch of decimal places. And again, anytime you want to use pi, instead of trying to write 3.14 whatever, you can use math.pi, and it will always have the right value, or at least the right value up to a certain precision. Okay, so we enter the radius, the area is the radius, and here we're using the exponentiation to take the square of that, and the circumference is twice the pi times the radius. All right, so here's where the decimal format comes in. So here are the little hash guys here, and then what the 0 does is the 0 says, make sure that you actually put something there. So if there were, this is sort of a subtle thing, if you happen to use this, if you put a 0 instead of a hash, then that says you got to put something there even if it's not there. If you put the hash and it doesn't, like for example in this, if there are only 2 decimal places to the right, then it will only print the 2. It'll leave the last one off. Okay, so here's how it comes out. If we give a radius of 5, then the area was 78.54, and the circumference was 31.416. Okay, the other way, and the book doesn't talk about this too much, so what I'll do is I'll be posting a little handout that will go through the different values for printf. Basically what happened was that people especially coming from the C language, were really kind of not happy with this way of formatting things. And this is what, and so after several years of lobbying, what they convinced the Java people to have a more C-like way of formatting the output, and that's what this is. So we've been using printline up to now, but there's another option called printf, and the syntax of that is there's a string which is kind of the format string, and then the rest of it are a list of the different arguments. So here, at least the popular formatting characters. So if I say %s, that means formatted as a string. %d is for integer values. %f is for floating point values. %b is for Boolean values. %n gives a new line. That's in this format. For whatever reason, the \n was problematic. There are a few others. There's one for time and dates and things like that, but I don't use those very much. So these are the more popular ones. So for example, so here are some examples. So again, printf is a an instance method. Okay, remember instance versus static. So remember, system.out is an object. This is an object. And so printf, like print line and print, is an instance method of the system out object, which is the type is the class, the actual class is something called a print stream. You don't need to worry about that. Okay, so here, if we want to print a string, so here we use %s, and then we want to use a new line. Unlike if I want to use the equivalent of print, then I just leave off the %n. But okay, so %s, this will take the first argument and stuff it into that, and then put it on one line and then give a new line. If I want a number, okay, so, well, in this case, number meaning integer, I use %d. So here I've given it the number 42, the answer to life, universe, and everything. And here it prints the number. Okay, so what I can do now, and this is why this can be a little bit nicer. If I have data that I want to print, you know, either on the console or I can direct this to a file. That's actually my biggest use case for things like this. What's a little bit nicer about the printf is that I can put all of that on one line instead of having to kind of, in other words, I can format the line the way I want that to be, and then put the data afterwards, and it just sort of stuffs it into the respective values. So, okay, so let's look at this. I want a string, an integer, and a floating point number. I'll unpack this in just a second. Okay, so here's the string. So here are, you know, notice the concatenation here. Here's the integer, and here's the floating point number. And then here's what it prints. Okay, so the %d is what produced this. Now, %f is for a floating point, but then notice that I also put in a 0.2. So 0.2 says only print 2 decimal places. And that's what it did. So notice that there were actually 3.1 instead of 0.126, it printed 0.13. So it's not clear whether, how should I say, it's like whenever you're doing something like this, is it going to round or truncate? It's not a law of nature. It's just something that the programmers arbitrarily, the people who wrote the language arbitrarily decided, and they decided to round it. Okay, so so you can, you know, for me personally, I find this to be a little bit more useful than the other. The other thing is that I don't have to instantiate extra objects. I can just kind of do it. Again, your mileage may vary. So when it comes to you doing it, either way is okay. Now, one thing to notice here is that, say, when I have this number here, it's, especially even if it's a little bit longer, it's useful to be, I would prefer, like when I'm reading this, to have this look like this, put a little comma there. And if I'm in Europe, by the way, Europe inverts the comma and the period. So if I'm in Europe, this would be a comma and this would be a period. That's interestingly, Java takes care of that with something called locales, which we will not deal with. A couple years ago, there were some German students, and so using the German locale, they were able to format their numbers in such a way that looked just like them, and they didn't have to modify the basic code. They just had to specify what the locale was. Okay, so but this issue about using, you know, here in the US, we use commas to separate large values. So here's a big number, and here's how I use it. I put an extra comma in the case of an integer before the D. So here I'm printing this number, and notice that it puts the commas every 3 places. And then we can add the same thing for floating points. So here's a floating point value that's in the millions. And so what this says is, okay, this says, let's unpack this. Moving from the right to the left, it says use 3 decimal places to the right. And for the left of the decimal places, separate them by a comma. And if the comma is not necessary, it doesn't put it there. So under the hood, it just kind of does everything that you would want it to do. So again, let's take a look at this. Here we had 4 decimal places. It rounded it. So instead of 5, 6, 7, 8, it said 5, 6, 8. And then it put a comma every 3rd one. So that's the printf one. And again, I will be posting a handout that has the more of a reference for all the printf stuff. Again, that's my preferred way of doing it. When I ask you to do something like format it according to this, you can use either the number format or the printf as you see fit. Okay, I have a couple of examples that I'm going to show you, but just before I forget, so in addition to finishing this chapter, we're almost done with it. And I want you to also start reading the following chapter for tomorrow. Okay, so what I want to, let's see, what we'll say. I think this was, yeah. Okay, so what I did was I redid the book's example using printf instead of decimal format, just so it's just how you can see it. So I was using exactly the same logic. So the idea is that the radius was going to be an integer. Again, normally that would be a floating point, but that's for the sake of this example, again, it's useful. These are local variables. And again, when we kind of circle back to the different types of variables and their visibility, we'll understand that this is one of the 3 kinds of variables that are possible. Just to reiterate that, we've seen instance variables, we've seen class variables or static variables, and then this is the 3rd one, local variables. So, and that has to do with something called scope, which you'll hear me talk a lot about. Okay, so here's our scanner. We're going to enter the circle radius. Now, here's where again, we haven't talked about flow of control, but you've all seen the if-else statement. And when you're entering something like this, what's fragile about it is that if and you might have encountered this in some of the other stuff, if you enter something that's either a string or even a floating point number with a decimal point in it, or anything that cannot be parsed into an integer, then the program just bombs. And instead of bombing, what you should do is you should test your input. So here's the scanner has a nice test called has Next Int. And basically what that allows you to do is say, if the next token is an integer, then this will evaluate to true, and then I'll be able to input my radius. If it is not an integer, then what I want to do is I want to just bomb out. And I'll show you how that works. Okay, so here we're using our math pi and the circumference, the math pi radius, and then here we're using printf. So here, the circle's area here, I wanted 3 decimal places. So it was separated by a comma. And likewise for the circumference. So when I run this, let's run it. Let's run the book's example. Okay, now one of the differences was that when I say I want 3 decimal places, then it's going to give me 3 no matter what. So this is one little difference between this and the and the number format, which those little hash things would. The thing about the hash is that if it's the rightmost place and it's a 0, it won't do it. Okay. All right, but here's where. All right, supposing you enter something like this. Okay, what I've done is I have said, okay, now notice that instead of system out, I said system error. So system error is another object that's a print stream that actually kind of prints things. That's the error. It prints it in red to say, hey, something bad happened. Let me show you what would happen if we didn't do this. Okay, so if we did not do this, then this is what would happen. Okay, the input mismatch exception. Okay, so since these runtime things can happen, I mean, just in general, and we haven't talked about the if yet, but you all know what an if else is because you've seen it in other languages. You always want to make sure that your data is okay. Now, just to, if I enter a large number, then because of these commas, it will print the area and the circumference with the commas. Well, this one with the commas. Oh, and then just the examples that were in the slides. Again, all of those are kind of here that you can just sort of check. So if I have a string that I want to, obviously I could just, if I'm going to do this, I'm just going to use a print line. So that's, but if I'm going to print a number and I want to kind of have a little prompt, I can put those all together like this. And then some more numbers, the big numbers like this. So those are all basically there.